Hi, Algebra 1B students. I am very excited to welcome you to the final project questions for this course. We are on Lesson 29, Unit 6, so Project 6, Lesson 29, and we have 4 questions. Here's the background information. Functions that represent situations are often modified when the situation changes. These modifications can be done using transformations like translations and dilations. Use your knowledge of transformations of absolute value functions, piecewise functions, and step functions to transform the functions that were defined in lessons 26, 27, and 28. Okay, so first question, we're going to kind of go back to that absolute value problem. Recall the game of pool from lesson 26, and we are going to figure out the situation where Rainey miscalculated and missed her shot as outlined in lesson 26 project. Because the 8 ball was actually 1 unit to the left of 8 and 5, along with the rest of the points in the absolute value function. So everything needed to shift over 1 unit. So what would the new coordinates be for this 8 ball? So she's not shifting anything vertically, she's just shifting horizontally. So if we're here at 8 and 5, our vertical coordinate will stay the same, but 1 unit to the left is going to put us at 7 and 5, okay? So that's a pretty easy one. Let's just type that in here. Okay. Refer to the absolute value function defined in questions 1 through 3 of 26. And we can look back at that if we need to, but identify the mapping statements and the image of translation that shifts the function 1 unit to the left. Okay, so if you will recall, we had, I'll just provide you a little background here. We ended up with f of x being equal to 5/4 times x minus 12. And our k value there was 0, so that's all it was there. And so in this instance, we want to end up with x minus 11, right? Because everything, they just told us that everything, including our vertex, is going to shift 1 unit over. So now we need this 12 to go over here to 11, okay? So how are we going to get there? Well, okay, so we have to map this from our original f of x to, instead of x minus 12, we have to add 1 to that, okay? So we need this to be f of x plus 1, because remember, a plus 1 is going to shift us over to the left. So this is mapped from here to here. I'm adding 1. Okay, and when I do that, then remember that I'm going to end up with that 5/4 still times x minus 11. And now that is my g of x function, okay? So that's my new function, my mapped function. Okay, I still don't have a k value because I'm not moving vertically. I'm just making that horizontal shift. Okay. Cool. Now we're going to look at our piecewise function. And if you'll recall, this was the cost of t-shirts, okay? And we had different increments where the cost would go down. So refer to the piecewise function for lesson 27. The league organizer, it turns out, is able to get a $25 discount on the total order of shirts. So total order, regardless of the number. Well, that's pretty cool. So what is if our mapping statement is f of x is mapped to f of x minus 25, then remember for each of those, we had f of x equals 20x, f of x equals 17x, and f of x equals 13x. Okay, well, all we're doing here is subtracting 25 from each of those. Okay, that's all that mapping statement says. So I can eliminate at least a couple answers here. I can eliminate this answer because I'm not subtracting 25, and I can eliminate this answer because I'm not subtracting 5. Now I just need to pick the right range, right? So the number of t-shirts that we're getting each of these prices for isn't going to change at all. So if you'll recall from lesson 27, we were going to pay 20x for 0 to 25 shirts. We're going to pay 17x for 25 to 45, and we're going to pay 13x for x is greater than 45. So this g of x here contains not only our new function, which was our old function minus 25, but it also has the right subdomains. Okay? All right, question 4, the very, very last question. Refer to the step function defined in lesson 28's project. A day camp for younger children, requires twice as many counselors. Okay, so when we were at 2, we'll now be at 4. When we were at 4, we'll now be at 8. And when we were at 8, I guess, did we ever go to 8? When we were at 6, we'll go up to 12. Okay, so what is the result of that? So we're not changing the number of children, we're changing the number of counselors. So this first function has our right g of x values for 8 and 12, because that's the double of 2, 4, and 6, but it also increases the number of children, okay? It's going from 2 to 20 instead of from 1 to 10, so that is incorrect. Okay, these two functions didn't double our number of counselors. They're still at 2, 4, and 6. So this last function here not only doubles the number of counselors, but it keeps the number of children the same, which makes sense. If you've got younger children, you're going to need more help for the same numbers of those children. Okay. All right. You can now submit your final project. And I will look forward to grading these and issuing final grades. Thank you so much for joining me.